Very good morning, guys. I hope all of you are doing good. This is Ishant on behalf of Auribises. Guys, we're gonna understand what is meant by image classification today. So, I got some small data set on COVID-19 chest X-ray where we got some infected images and some normal images, right? So, what we have to do is we will be writing one CNN model which is going to perform this image classification, and we'll be doing this with the help of TensorFlow. All right, so let's begin with it. So first of all, let me show you where is this data set. So this is this COVID-19 data set available. Now there is this folder called COVID-19 dataset. In this folder, we created two folders, test and train. So test and train further contains two folders, COVID normal, COVID normal. So what you need to understand here is this, that there is a certain hierarchy which you need to follow. Okay, so what is that hierarchy? So if you have to create image classification data set, right, and you need to solve it with the TensorFlow, so you need to ensure that you got this data set divided into test and train, and you got these further folders in which you contain, which will put some images, right? So COVID represents the first class and normal represents the second class. So in the COVID, we got some of these chest X-rays where we have the infections for the patients. So if you'll open this, right? So this is the kind of some chest X-rays which are available. These are the images, right, with the infections. And thereafter we got these normal ones, right? So normal ones are already available, right, which are clear through any infections. Some of the data sets right here and there. Thereafter, what we got is we got this training data set and the testing data set for us. So COVID training contains more images, right, as compared to your testing data set. Now we need to write our CNN model, right? So we have this data set available with us. So I just copied this data set into my folder here, EMC 2020P1. So this is the data set, COVID-19 data set. So this is test and this is train. Now, if you need to work with the Flask application, so you need to write a UI where you can actually pick up these files, and you can or the zip folders which you can use here and there, and then you can have the UI elements. But we'll see that very soon over the time how we can write a complete Flask app with respect to your TensorFlow image classification solution in the future. So what we're gonna do is we're gonna follow one of the tutorials in the TensorFlow in order to solve the same problem. We're gonna work on the same path, right? So it's not like we have to work very differently here. So yesterday I gave you one of the problem to be solved. So I don't know how many of you had done it or not. So I gave you to work on something known as image classification, to look through this problem statement. So guys, we'll be using a similar a part, but here if you see, right, so Google worked on cats and dogs data set. So we have a different data set and we have a different way of dealing with it, right? So I'm just taking in a bit different way, not exactly in the same way. So the first thing first is let us import some necessary libraries. So I'm gonna import this TensorFlow as TF. So from the TensorFlow dot Keras dot model, I'm gonna import something known as sequential. So this is what we did even yesterday. So we got few of these imported here, right? So models, layers, and the data set. So similarly, you're going to come up with these things. Now, sequential is the model which we are going to use, and there will be some layers involved. So for the layers, I'm gonna have this layer called dense. Then I will use a convolutional 2D layer. I will use also something known as max pooling 2D. Then I will be using something known as flatten. All right. So this is what I'm going to use when it will come to create the model. But the data set I have is images. Now all these images, they may be of different sizes, and there may be some different resolutions. So coming here, so let us say that there is this image. If you see the image here, right, we'll just try to see what is the size of this image. All right, so okay, so here we are. So if you see, the size is 2563 by 1148, and the resolution is 300, right? So I got this size as 8133. Let us open this second image. So if you see here, so this is 1165, 1163, but the resolution is 500. Width height is small, and here you got the size as 199 kb. So what we understand is that all these images are of different sizes and maybe different resolutions. So TensorFlow give us an API for image manipulation, right? So TensorFlow dot Keras dot preprocessing dot image import something known as image data generator. So guys, this is the API which we are going to use to pre-process our images available in our data set. So I'll even try to draw the training and the validation accuracy and loss over the graph. So I'll just say import matplotlib.pyplot as plot. So somehow my PyCharm is giving these errors here, right? If you can see. So this certainly is because a few of the libraries are not correctly indexed in PyCharm. So I'm just gonna say print. This is image classification model creation. Let us try to run this program and see if every import is going to work fine for us. So here you are, right? So every import works fine. It means that these are just the errors which are the kind of bugs for us here in the PyCharm. Now, the first thing first is that you need to somehow create your data set which you can feed to the CNN model. So CNN model we have already seen, guys. So what I will do is I will say something known as train image generator, which is going to be your object of image data generator, right? I'm going to create an object of image data generator. Now I'm just gonna write you can say few of the things here and there, right? In this image generator, right? I'm going to come up and let's say that there is something known as rescale, which is going to be 1.0 divided by 255. So what I'm seeing here is that I would like to come up and kind of rescale all the images. Okay, so to this 1.0 by 255. So this is my train image generator, and same way I'm going to say test image generator. This is also of the same scale. Now my training data. So training, let's say images. So the images on which you would like to train the model, right? So you say train image generator dot flow from directory. So this is the API which we are going to use. Okay, so flow from directory. So it means I would like to read the images from the directory. And when I will read these images from the directory, so there are few inputs which I'm going to pass to this function. Let us see what is that. The first input is where is the path to your training images. So in my COVID-19 data set, so I got this COVID-19 dataset slash train, and this contains two classes, COVID and normal, right? So I'll just come here and say COVID-19 dataset slash train. So what is going to be the target size, right? So if you're gonna read these images, you wanna pre-process these images. So I'm assuming that images should be pre-processed to a size of 64 by 64, right? So that's like the target size. And if you want, you can do this in a batch. So batch size may be 8. So 8 images in a one go. And we are looking forward for the class mode, which must be binary. So we are going to deal with the images in ones and zeros, if you can recall our yesterday's discussion at the same time. So training images, right, shall be obtained from the train image generator, which is going to read the training folder of our COVID-19 dataset, which further contains two classes, COVID and normal, right? Now, same thing, I'm going to put it over your testing data, right? So same way you have testing images. So instead of train, I'm just going to write this test, and this guy is going to be your test image generator. So guys, can I get a smiley from all of you? Are we good to go till here? Can I get an acknowledgement from all of you as a smiley if we are clear till here? So what we did, we are created image generators. Image generators are going to rescale the images, and when you read from the directory, so we would like to have the images in the binary format, and the target size is going to be 64 by 64. Now this way you are going to pre-process the images, and you are going to make it more simpler for your neural network, right? So let me run this program now. So what we see now is there are two of these print statements which are automatically coming up. When you executed this flow from directory function, so this guy printed one statement, found 130 images belonging to two classes, and found 18 images belonging to two classes. So always remember, your test and train model directory for the image classification should contain the subdirectories, which are the number of classes. It means what? If I want to create a data set where I would like to distinguish two different people, so I need to work on two different directories, maybe the John and the Jenny, right? Or maybe if you want to detect from the photograph the gender, there may be male, there may be female, or there may be 10 different classes here, right? It depends upon what is the kind of image classification problem you are solving. Now in case in the field of agriculture, so there can be plant 1, plant 2, plant 3, plant 4, plant 5, so on and so forth, for the training and for the testing. So here we are solving the problem where we are trying to understand that there may be the COVID patient, or there may not be the COVID patient. Okay, so guys, let us proceed further. Now the next thing is, and one more thing, right? So we are not doing a medical AI model, so that requires so many other parameters to be examined, and this is again one of just a demo study for you guys to understand what is image classification. We're not working exactly on kind of real data sets. Okay, so these data sets are over the Google, may be correct, may not be correct. So next is what I'm going to write this function called plot me the images. So we'll try to see images, but what images you would like to see. So I'm going to say, so these are training images, right? So I'm gonna create a subset of the training images, right? So let's say sample training images. So they are like what now? So there is this function called next. So if you execute the next function on the training images, right? So you need to execute the, okay, so I think so guys, one small thing here, just give me a moment. Okay, so when I will execute this, so the next function is going to give me two components, right? So I'll just put here one small program. I mean, I'm just gonna say plot the images, but from the sample training images. So I'm just going to kind of read the only first 5 images from 0 to 4. Okay, so I'm just going to read these 0 to 4 images for me. Okay, so what are the images which I want to read? I'm just gonna show it. So guys, I'll very quickly write this matplot. Figure and axis is going to be plot dot subplots, and these will be 1 to 5, and for the figure size, so let us take it 20 by 20 figure, and your axis are going to be your axis dot flatten. So you're gonna flatten the axis here, and now for image and the axis in the zip function of the images and the axis. So guys, we are going to draw these images over the matplotlib. So I'll say axis dot image show this image, and so axis dot axis is supposed to be turned off. So these are now this is the standard way, right? If you are going to code any CNN problem. So last one is we're going to have the tight layout for the plot, and we're gonna show this plot. Let us try to run this program and see what happens now. Okay, so maybe the size of this plot is very large. So here we are, guys, right? So these are the images which we sort of read from the data set, and these are the training images which we are able to plot on the matplotlib. So it's just the way of plotting, right? You can plot it the way you want. So what we didn't plot the images directly from your directory onto the matplotlib. So we got this kind of pre-processed images from the image data generator to be shown, right? So this is the way how you can anytime come up and see what is your images, what are your images, and how do they look like. So this was our step number 1. Okay, so if you want to do the image classification model creation, so in my step number 1, So you need to do image pre-processing. So that is what we did. So in the image pre-processing, so you got this image data generator API, which is going to help us to have the images in the binary mode so that we can train the model. Now let us create the CNN model here. So I'm going to now say step number 2 for us, right? So create CNN model. Let's see how it's gonna be. So you create the model which is going to be your sequential, right? The object of sequential, that is something which we are going to write, guys. We are going to create a sequential model here. So in the sequential model, we are going to add the layers of the convolutional part, and we are even going to work on something known as the max pooling, and then the flatten and then the dense, right? So guys, model. So what I'll do is I'll very quickly pick up the stuff from our yesterday's session and not waste much of the time here. So we can just change anything which we want in this code. So model is the sequential. So I'm gonna add the convolutional 2D layer, then the max pooling layer, then again the convo 2D layer, max pooling. So let me just quickly fix this for you guys. Okay. So the size for my input image is 64 by 64 by 3. So here, so you are going to use, let's say, the same 32 3 cross 3, right? And the max pool is again 2D. Then again, I'll go with 32 3 3 activation function. Let it be ReLU, the max pooling 2D layer, and thereafter I'm just gonna add a flatten layer. All right, and thereafter I'm going to add a dense layer. Since I got this image 64 by 64, this time I'll just try to take some 128 neurons for me here. And lastly, I'm going to have one more dense layer. This is going to be the output layer, the final output layer. And in this final output layer, so I got only one neuron, but the activation function I'm going to work is sigmoid. Okay, so anyone with any query here, guys? This is how we create a convolutional a neural network model. I hope till here we are good to go. Can I get an acknowledgement from all of you? So creating the CNN model, then your step number 3 is you're gonna kind of do a compilation on the model, and then you're gonna train the model, right? Two more things which we are left with. So here we are with step number 3. Train the model. So model.compile, right? So compilation is where you just specify this part, but loss parameter here is going to be something known as binary cross entropy, and the metrics be the accuracy, right? So this is what is the model compilation for us, right? And lastly, we're going to now say model dot fit, but guys, this time I will not say fit here. Okay, so the fit function typically works on other parts where you haven't used image data generator. when you use this image data generator to create the data set for your images, so you kind of use another API here, and this another API which I'm going to use is fit_generator. So just put this thing in your mind, right? So what I'm talking here is, if you are going to create image data set with the image data generator, then you should not use the fit function, rather you should use the fit_generator. I'll just put this small comment here as well. If we have used image data generator for our image data set creation, so you got a different API to deal with it. Okay, now what is this next thing for us? So the next thing, I'm going to have these training images. So you need to give the training images, you need to find and you need to put up the epochs. So I'm gonna work on 5 epochs. I will not be working on, even though the data set is very less for us, but you can work on more epochs so that you can have the good amount of training and the testing set done. So the validation data is going to be my testing images. All right, so we are going to train our model and we'll see what is the loss and the accuracy when we train this model over the training images and the testing images both. Okay, so this is the data with respect to which we are going to validate our trained model, and this is the real data. And of course, yes, your training and testing data is from the different directories, the training images and the testing images. Now let us come here and do some more of the parts, as in, so when I will train this model, I will get some valuable parameters in the history. So in the history, you get these keys called accuracy loss and validation accuracy validation loss. Okay, so I'm just going to say accuracy is your history dot history. So this we have already seen, guys. I'm just going to plot how this model is going to work for us. Okay, then validation accuracy is going to be your validation accuracy. So 2 of the accuracies will get, and same way will get 2 of the plots. Okay, I mean losses. So I got this loss and the validation loss. So this is loss and the validation loss. So from the history, you get over the 5 epochs, right? So these are like 5 epochs for us. Okay, so what I'll do is I'll say something known as epochs range, which is going to be your range of 5. So you got this 0 to 4 accuracies, 0 to 4 losses, and 0 to 4 validation accuracy and the validation losses. Okay, so guys, let us now create a plot. So I'm gonna say a plot dot, let's say a figure first of all, and I'm going to give this figure size. Now this is exactly up to you, right? It's not mandatory, it's optional, right? So let us say an 8 by 8 figure, then plot dot subplot. So in the first 1 to 1, right? So we'll do a plotting here, and this plotting shall be done over the epochs range. So x gonna be number of epochs, y is going to be accuracy, and I'm gonna give a label here. So label is going to be training accuracy. All right, same way we got this validation accuracy. So you're gonna compare both. Okay, so you're gonna compare both the accuracies, and thereafter I'm gonna say plot dot legend. And guys, if you wanna give the location of the legend, you can even do that. So I can just say a location is going to be a lower location, and lower in the right hand side. Maybe upper left, you would like to get in the upper left or upper right, it depends upon you. Okay, so what location you want to come up and put here. So this is for the accuracy, and you can see I'll just even give a small let me just give a small title here. So plot dot title, let's say this is accuracy, right? So the same way over this 1 2 and 2, right, I'm going to have this another image and another plot. This is going to be for the loss and the validation loss. So anytime you create any model in your AI in the deep learning environment, so you always try to compare these losses. Okay. So from these graphs, you'll be able to see that whether your data is fitting correctly or not into the model. So this is lower right. So let us say this is going to be your upper left. Let's change it, and this is going to be training loss and validation loss. So we understand whether the loss decreases over the epochs or it remains the same, or how it is different from training and the validation data set. So lastly, let's say plot dot show. So once you train the model, in my step number 4, we are visualizing. So you are kind of visualizing your loss and accuracy, so that you can take up the call whether I have to work on the same model or not. Okay, so that is the reason why we are dealing here. So let's run this program now and see what happens. So I just commented off this plotting of the images. Okay, so we are good to go with the training now. So these are just the warnings from the TensorFlow. And of course, yes, in case you are unable to work on your system, guys, you should be working on your Google Colabs. And of course, I have these little number of images, so we cannot rely that okay, the model is gonna work perfectly fine, right? But at the same time, I can see that the loss has significantly decreased and the training part is quite good. So here we are, right? So training accuracy increased, but this accuracy for the testing or the validation remained the same way. So this loss is significantly decreasing. So what I see is that these graphs here, they are not exactly in the similar lines, right? So I was expecting that the accuracy for the validation should also go in the same way. Now, what I'm expecting is that these curves, they should be very much near to each other. But there's a problem of overfitting or underfitting of the data. It means that your data set lags in the information. So this is the kind of the graph from which I need to make up the decision that okay, is my model perfectly fine or not. So what I see is there is a lot of gap here and gap here. So these two lines, they are having a quite gap. So we cannot kind of think that okay, this model is going to work fine for us. Okay. Now what we should be doing next. So this is the phase 1. This is the first part here, right? So I'll just put up these comments. After the observations on our training and testing images, we would not have found the correct modeling for our data set. So you need to understand that there might not be a correct modeling for our data set. So what we need to do is, there are two options. Number one, so either we gather more images and more meaningful images and work again to train the model. The second part is perform image augmentation. So what is meant by image augmentation, right? So guys, so from the training images and testing images, we gonna create more sets where we flip the images, rotate the images, etc. Right? So there may be a use case where what we will be doing is we'll be playing around with the images which we have. So we may rotate the images, flip the images, do some more actions on them, right, here and there. So that is what you need to do. So from here, this second point I'm going to leave on you. Okay. And one more thing which you need to do is to thereafter, once you are done with this, you need to check your accuracy and loss. Okay. So let me show you how you have to do it. So let's come here in the TensorFlow tutorial. So for image augmentation, so you need to follow this tutorial here. So here in the tutorial, Google and we have done the same job, not the much job. If you see here, so this training accuracy and the validation accuracy or a loss, they are quite they're differing, right? So they are quite off large by the margins, and this is not the thing which we are expecting. So we need to come up and do the augmentation, right? If you see, there may be a case that you generate the image data set by saying horizontal flip to go as true. Then once again you read from the directory. Okay, so what you will get is, you will get that you have an original image and your original image has been flipped to the horizontal here and there, if you see now, right? So it's gonna randomly flip the images from your image data set, and hence you get some more instances. The other way around is, you do a rotation on your images with some angle, let's say 45. So here the same image may be rotated, and of course you get more samples to test on. There may be applying the zoom augmentation, so your images may be zoomed up, right? So you got these various different ways. So we can have an image data generator which can generate the images by doing a rotation, by even doing a horizontal flip with some zoom range of 0.5. So this way, if you are going to create your image data set, there may be a case that after this, if you will kind of create your model and then you train it, so you'll understand that your training and the accuracy and the loss are pretty much in the similar lines, if you can see from the graph, guys. So I'm leaving this partial implementation that you have to do some image augmentation, right? So that's just like that, you need to come up and change your image data generator, and you need to work on that. So can I get an acknowledgement? Can I get a smiley from all of you? Can you do this? And one more last part which I'm going to leave it to you people is a part of your homework. Predict the class from the given image to the model. right? Whether the COVID-19 is positive or negative from our data set. So first of all, you need to do the image augmentation, and then you need to give the prediction on the class, right? So I'll be expecting an acknowledgement in my WhatsApp group that you guys have done it. In case you are unable to perform this in your system, please do work on Google Colab. But I'm expecting an honest reply from all of you that okay, we worked on the image classification. Now from here you will always understand that the project development for you guys, the wings may be open now, so you can do a lot of things when it comes to the image classification. It's just not one basic part here. So this will be all from my side for the day, guys. So we'll be meeting very soon the next week, and we'll try to kind of summarize the training content by next week. So wish you all the very best. Have a great weekend. Happy coding, guys. Thank you so very much. Thank you.